So first of all, thank you for taking the time on a weekday, especially in Mumbai traffic. And its time is, what I always feel is the most important thing. The people who are the most wealthiest in the world value time more than money, right? You make your best use of time. So I'm great to be here. So first of all, I think we are launching KX in India, and I work in New York City, in Wall Street. We have pretty much all the world's largest and the best banks use us in Wall Street, but Mumbai is the Wall Street of India, and we weren't here. So I'm really proud to launch KX in India. And I think a couple of weeks ago, I saw that Sam Altman made a comment about India. Indians will not be able to create a GPT, or maybe he didn't mean that. He just said, don't spend money and effort on creating foundational models, or it won't work. And I just read an article which got published about Altman to Altman, because it's almost, India is actually the one which has the best opportunity in the world in terms of leading in AI. So as we go through, we'll kind of cover what AI really means in the context of economics. And there's a lot of hype, whether it's generative AI or everything else going on. Is it going to take away the jobs? How to think about AI? How can you differentiate as companies, as professionals? Because if everybody uses ChatGPT and everybody does the same thing, how do you differentiate yourself? So those are some of the things. And then what happens to the jobs as we know it today? And in the context of what we do at KX, so I want to kind of share some examples and use cases. And we'll do a quick demo in terms of some of the largest companies, how they differentiate themselves, and how we can kind of combine generative AI with discriminative AI. We have been doing AI for, like Neelkanth said, for many years. So with that, I think one of the things I find, if you start with the boardrooms, for those of you in your companies, obviously the boards are very interested in generative AI, but there are different aspects of it, right? I think there is how do you find the use cases, what helps you differentiate, but also people are worried about, how can I create explainable AI? How do I make sure that it's not just a black box? And if you're in the financial services, when you make decisions, how do you know why, what's the why behind it? So to some extent, I think these are some of the things what people care about in terms of then, if you're using GPUs and using lots of electricity and power and compute, and how do you create sustainable goals? So these are some of the elements. We'll kind of cover that, but I just want to start with what do boards are asking what you to do. Then if you're a C-level executive or a CEOs in your company, most people are thinking about generative AI and AI, but it starts with the bottom, which is really, if everybody uses the same things, OpenAI and Bard and other things, and you get certain level of productivity and efficiency, how do you find what's core for you? How do you differentiate yourself? So it's really, I think it comes down to what we call a golden AI use case. Basically, what differentiates you. And one of the things is really comes down to your own data, your own knowledge in the company. It'll become a strategic asset. Otherwise, you're just going to do something which is non-core, and that ends up being everybody does the same thing, and you can automate things, you can do things automatically, you can write emails, you can generate content, and you don't even know where the content came from. But how do you differentiate yourself? So this is when I talk to quite a few companies and customers worldwide, and this is on top of the mind of CEOs. And then I think for those of the people in the practitioners, we work with a lot of the world's best data scientists, quants, the data engineers, developers. For their perspective, this is something Gartner did a survey recently, which kind of talks about what will happen to some of the roles with generative AI and AI. So you'll see it's moving from people who are developing software, because I think ChatGPT released a code interpreter. It generates a lot of the code. It's very accurate in terms of you tell it in English what you want. They say English is now the best programming language, because you can write everything. You ask something in English and it'll generate. So what happens to the developers? What happens to the different roles? So what we are finding is it just becomes more, there are always roles, but you start thinking about a different construct. There are roles like prompt engineering, which is really becomes, how do you frame the problems, the business problems. It's not just about asking different questions, but are you able to create the right type of problems and frame it so you can do that. And so governance is a big question. I think many of you, how do you make sure that there's no hallucination? What is the cause and effect of things? It's not just correlation. So those are some of the things what many people will have to think about. It's not just about just taking some model and generating something, but what happens in the future, right? So when like horses went away with the cars, but there's more jobs. When the iPhone came, everybody thought a lot of things will go away, but then there are more people using iPhones, but there are more people are productive. So that's one of the things I wanted to make sure that, in terms of the three aspects, the board, the CEOs, and practitioners. And then I think the question I always, when you look at what is AI really giving us, and I think some of these books and research, the University of Toronto is the world's leading AI institution. The father of AI who left Google and is talking about AI for safety comes from that. So they have got this theory which we believe customers, when you look at what's happening, end of the day, AI is about prediction. It's a prediction machine. It helps you make better predictions so that humans can make the decisions and judgments. So if you can separate out the prediction from decision making, and if you lower the cost of prediction, just like the computers lower the cost of computing, this is aspect of it which we find you'll see that more and more. How do you kind of help humans make the decision and judgment and wisdom, and you separate the prediction. So I think this is something which I kind of will take through this thing in terms of what we help with, because we have actually been in the business of helping with predictive analytics over many years. That means you're making decisions based on statistical data, but now how can I use AI to lower the cost of prediction so that humans can still make better decisions in whatever field you are? Or if you're using that to get your machines to do trading, or you're doing machines to do all these chatbots. So think about it as AI, at the end of the day, is about economics of how do I lower the cost of prediction. And if you design your systems where decisions are separate from this, it gives you an advantage in terms of how to innovate. So the other thing, in terms of the evolution of where the opportunity is, we all have been doing AI all these years, right? Maybe it's traditional machine learning. Supervisory learning is what we started off. That's the biggest area. We started classifying things, whether it's junk mail or email or whatever, you kind of label things. Then we went to unsupervised learning, where you look at a bunch of data and be able to classify, find patterns. And then now the generative AI is coming in, and you can see the type of applications as we go from, how do algorithmic trading. So many of the companies who use our technology, the top banks everywhere, right? So they are using it for trading, machine learning, but now they're moving towards how do I combine quantitative information. If you want to forecast what type of stocks you want to invest in, which beats the Sensex index, you can use some of it, but then there are lots of things happening in the market, whether it's sentiments, somebody is upgrading the stocks, there is management changing in a company. There's a lot of qualitative information you need to consider, a lot of things in text and videos and others. So now you're able to bring that together. So whether you want to do better fraud detection, because generative AI will help you to generate a lot of synthetic data, different scenarios, that will help you to lower your risks, and you can do risk modeling. So it's kind of a continuum. It's not necessarily that you just do things in generative AI, but you combine what we call a discriminative AI, which is the data-driven approach, with a model-driven approach, and you can get to a better decisions, lower cost of the predictions by combining these things. The opportunity, again, one of the things, this is a framework we've used with customers. What you find is there's two types of AI. If you start with the things what I just talked about, data-driven discriminative AI approach, you use data to come up with algorithms. You come up with, how do you pricing, forecasting. One of the biggest decisions everybody makes is about the future. So time is an element which all of us don't know what will happen in the future, just like the weather in Mumbai. If you want to know what happens in the stock market, what happens to anything else, how do you actually do that? So that's the hardest part, but then we use data to predict some things. But on the right side, you have the generative AI, which is all about content. It's trying to predict the next word in the sentence. It's kind of coming up with taking all the data in the world, especially what's available in public domains, Wikipedia, whatever the corpus is trying to predict the next word, next sentence, and our next content, next image based on. So it depends on what data it's trained on. But what it doesn't understand, if you ask ChatGPT anything about time, it says, I cannot forecast things. I cannot answer questions around numerical numbers, right? It ends up answering things which are also, the last thing what it has trained on is September 2021. So what's missing is addressing the numerical data. You can't have time. There's no statefulness in what you do in generative AI. What you learn is based on static information, and if that changes, you actually get something what is generated based on not understanding that time. Machine learning by definition is learning by experience. If the experience changes by time, what are you producing, what are you generating? So that's the aspect what you'll have to bring together is always bring statefulness. When Bard was initially announced, Google lost almost $100 billion market value because it answered a question which didn't understand time. Because it takes statistics. If people are talking about something more in recent years, statistics tell you that 99% of it is probably this next word I have to generate is based on the statistics. It didn't factor in time. Humans understand time. So one of the things, I have next week in New York, hosting an event where Dr. Manuela Veloso, she's the head of AI research for JPMC. I met with her sometime, and she talks about AI can count but not color. What she talks about, she used to be the chairman of Carnegie Mellon Machine Learning AI for many years. And as you know, Carnegie Mellon is #1 in computer science. And she talks about having that. So what you have to do is to think about how do you combine the things on the right and the left to bring things which you can use that as your golden AI use case. So how can you find things which are better, and whether it's risk models, or how do you find something which is an anomaly, which is a dissimilarity search? So that's really one of the framework what we have seen working with customers. And for each of the industries, people ask us, what is your golden AI use case? So to me, this is something which we are finding companies, like different industries, talk about. Financial services is looking at how do I come up with managing risk intelligently, providing market access. If you're healthcare, later on our colleagues from Syneos Health will talk about how they're solving, how they found COVID vaccines, for example, in 1 year versus 6 years by looking at simulating digital trials. So it's a similar type of thing, but going back to prediction, what I would like to say, think about this as, if you're trying to use AI to solve this, think about, again, framing this as prediction, or decisions you have to make, but how to make everything into a prediction problem. So I kind of took this approach, there's a lot of text here, but if you think about financial services, if you're doing risk management, you'll see that the prediction problem is how can we predict and manage the risk associated with trading lots of stocks. The key element is forecasting market movements, predicting potential risks. So it becomes more about how you use AI and data to frame it as a prediction. And you have the same problem in healthcare or manufacturing. This is just an example of how you do it. So in terms of what I feel, this is I'm kind of pushing this in terms of vectors and time. Generative AI, everything you learn, it turns unstructured information into vectors, numbers. So that's how you're able to make sense of, instead of searching by keyword, you're searching by meaning. How does something become a meaning is because whether I'm going to buy an apple is a fruit or an apple is a computer. It's based on the meaning you're converting so that you can go and search millions of records by meaning, by not keyword. So that, I think, is where if you add that into what's happening in the databases, we had different type of data over the years, you have database for relational data, you had documents, you had graph database, and now you have unstructured data. AI understands vectors. That's how LLMs, when they go and process all of it, they're creating vector embeddings for you, and you use that information to do searches, and you use that to train your own models. It has context. It doesn't have state, but how do you bring that? We can't talk about it. So that's the main thing, is that the biggest decisions in our, thinking about time and vectors. So humans, we use time to make a decision. A lot of times you don't consider time. The second aspect is machines also do the same thing, which is you can put things in sequence. That's what LLMs do, but they don't have the time aspect of it. So we think, KX as a company, we are focused on helping, whether it's Wall Street or healthcare professionals or the Ministry of Defense and Royal Air Force, who are using us on F-35 planes to decide, how to make decisions around whether it's an anomaly, it's a school, or it's a missile. Those are some of the things what we help with, both time and geospatial data, and applying vector technology now to bring generative AI. So I'll spend briefly a few minutes on what we do in terms of the use cases. Generally, with generative AI, many of the companies, if you talk to, will tell you what you can do on the right side, which is most people can do information discovery, being able to do text analysis, summarization, but not on the left side, which is anytime you have numbers, real-time, risk, you cannot do that, or at least that's what ChatGPT will tell you. And so the way we do it is really, we have got two things. One is, on the top, we take all the outputs from the LLMs and be able to help you manage semantic search and similarity search as a vector database for unstructured information. On the bottom, we do real time, and we can actually bring both structured and unstructured together to combine them together. So this is one of the unique things. What we do is we have large language models, but we also have large data models. So the biggest banks, whether it's investment banks, the most prestigious, Goldman Sachs, Morgan Stanley, JP Morgan, everybody uses our technology for doing what on the bottom, which is you process petabytes of data and also real-time data to make decisions, the machines which trade, and we'll talk about clinical trials and others, and then you can bring unstructured information, be able to do similarity search, and we'll also have a ChatGPT plugin, so you can ask questions in English, which you can use with Office products and others, so you don't have to always write code to do this. So that's at a high level, what we do, and I just wanted to quickly show a demo, and this is how it works. So this one, we are taking real-time data and market data, and we bring in SEC data, which is like unstructured information, be able to process it, create the embeddings, and then be able to query the response, and you can actually search over time. So let me show this.
This is a demo that combines structured and unstructured data using KDB AI with market data and SEC filings, and allows for an interactive time series similarity search all through dashboards. So we can enter a search phrase, and it does a similarity search against the text of the SEC filings, and it returns the top 3 most similar occurrences to that search phrase we put in. Because this is Apple, we can type in iPhone release, for example. This is going out and generating the embedding as we're creating it and doing a lookup. So these aren't preset bits of text that I'm searching for. I could type in anything I want. And then it comes back in real time as I'm typing with the three highest occurrences, 3 most similar results to our expression. We can just do a little bit of a sanity check here and see that's talking about the iPhone sales increasing due to the successful launch. So this also shows that it's not just exactly looking for iPhone release, it's looking sort of for semantics around that when we do the vector embedding. And now for the time series component, say we look, okay, over in this part here, there's a bit of a dip. I want to see when other markets dip, and I want to just see the most similar patterns to this pattern here. We can highlight that and click this accordion here. This brings up the most similar occurrences over a 180-day sliding window for against 180 other markets, and just returns the best results from them. We see that, so we use a frequency decomposition as the method of embedding. So the general shape is considered more than the actual values and how close they are. So we see this large purple line here. It follows the same sort of concavity as the highlighted region we selected, and then these other ones are the same, but maybe not to the same extent as that purple one. On the left here, we can then contextualize this because this is just showing us shapes of the data. We might want to see that in context and see it a bit more tangibly. Over here, we can select which company we want to look at, and then that will highlight it in context of the time of that stock where this happens. And we can click through these and see all these sorts of dips.
All right, so what we were trying to do was to show how you can bring real-time data, especially if you're a stock market. You can look at 50 years worth of data, for example, as new information comes in. You can go and find patterns, even in trends, and compare that to what happened. iPhone was released, and you're able to combine structured and unstructured information to make better this thing. So that's what we do is really at the end of the day, I think this quote comes from Syneos Health, for example. They'll show you our technology is built vector native, so that means we process everything parallel and simultaneously. So we can ingest data, we can store data, we can process analytics and AI. AI and data run together, they're not separate. So that's at a high level. I mean, there is, you can sign up for it, but also just as a, DB Engines kind of rates us. So we actually have been in this, you'll see the top line here, KDB is rated #1. We have been in this business for 20 years, and so if you're looking at other technologies like Pinecone and others started last year. So it's just, it's because of the way we have built the technology, and it's vector, it means it's processing everything together. So what I would announce is that the KDB.AI cloud, we announced it free for everyone in India. We can sign up for those people who want to try out, and it can be used. You can do both searches for similarity search for the time series or numerical data or unstructured data, and you can sign up on KDB.AI. So the last thing I'll talk about is really going back to the things what boards and CEOs care about, whether it's explainable AI, how you can create cause and effect, how do you remove bias, and how do you bring forensics. So those are some of the things what's built into our system, because that's really what we focus on. So when you want to do AI safety, when we talk about when the UK government focus, those are some of the elements. And so with that, thank you for taking the time. I'll be around to answer questions later on, and I'm going to hand it back to Neelkanth here.